Okay, today we are starting new topic, a new chapter, gravitation. Okay, this is quite an important chapter. We have the idea about it in lower class also you are studying. Okay. Newton's first topic is Newton's law of gravitation. Newton gave a law of gravity. Newton's law of gravitation. Okay. It states that the every universal bodies attract each other. Every universal body attracts each other with a force. Attract each other with a force which is directly proportional. To the product of the product of the masses of the two bodies and inversely proportional to the square of the distance between them. Okay. That is the Newton's law of gravitation. Do you understand by this diagram? Let us take one mass over here, two bodies of masses m1, m2. Separation between them is r. Then the Newton's law of gravitation says that force between them, that is force of gravitation between them, will be proportional to product of their masses, and the same F will be inversely proportional to the square of the distance between them. Second law is called inverse square law. Inverse square law. This law is applicable to the force, non-contact force, or force at a distance. Whenever force between the two bodies at a distance is acting, so the force is always inversely proportional to the square of the distance between them. Let us combine them together, these two. Then it will become as F proportional to m1 m2 by r square. We change this sign by a constant, that constant is g. We write the g m1 m2 by r square. Right, where g is constant called universal gravitational constant. And this g's numerical value is equal to 6.67 into 10 to the power minus 11. And this g will have unit. Let us check what unit does it have. From this equation we can check what unit it is going to have. G value will come Newton, this will cross multiply Newton meter square. Here we write it as Newton meter square divided by kg. Kg into kg is kg square. That means we can take kg to the power minus 2. Or per kg square we can write. So the SI unit of universal gravitation constant is this, and its value is this much in SI unit. We will find a dimension of G also. Write on the dimension of G. Physical dimension of universal gravitational constant. Dimension of G. From this equation we can find a dimension, or from the unit we can find a dimension. Unit is Newton. Newton means force, mass into acceleration. That means m/t minus 2 we can write into meter. Meter means length square. Kg is mass, that m to the power minus 2. And now simplify it and find the dimension. This will become minus 1 L cube T minus 2. This is the dimension of universal gravitational constant G. Very often they ask, give the dimension of universal gravitational constant. So this is the dimension. Okay. Why it is called universal? Because the value of G is universally true. Means the value of G does not change. At any point of the universe, the value of G, the is fixed, that is 6.67 into 10 to the minus 11, unit I have given already, Newton meter square, kg minus 2. That value never changes. Even if you go anywhere else within the universe, the value of G remains constant, will remain the same. And gravitational force is the weakest force in the nature, weakest. Why? Because of the lowest value of G. The value of G constant is the minimum, that is 6.67 into 10 to the power minus 11. Can you imagine 10 to the power minus 11 is divided by 1 and 11 zeros like that. So it is too weak because of the very low value of universal gravitational constant. And it is the weakest force in the nature. Okay. Now, next heading we give relationship between G and capital G, small g and capital G, relationship. Okay, so far the differences are concerned, they are completely different thing. How they are different, I will tell you. Small g is called acceleration due to gravity, it is a kind of acceleration. Whereas capital G is a constant, universal gravitational constant. The value of G on the surface of the earth is 9.8, which you round off and take it 10 meter per second square, unit is meter per second square. And the value of capital G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. The unit also different, dimension also different, value also different. They are completely different things. Definitely there is no question of difference between them, except the pronunciation like G and G, but one is a small g and the other one is capital G. But we find a relationship, how are these two quantities related to one another, what equation is there between these two, they will check that. For checking that, we will be writing this, that let us take earth, center of the earth is here. First let me tell you about this, what is called gravity. Gravity is the force with which the earth attracts a body to its center, towards its center. That is called gravity. Gravity is the other word for gravity is weight of the body. Weight means the force of gravity acting on the body. Gravity means the force of gravity, that is weight of the body, and it acts towards the center of the earth, vertically downward. The force with which, that is a kind of force of gravitation only, the force of gravitation on a body towards the center of the earth is called gravity. Whenever we center of the earth we involve, we say gravity. But gravity term we do not use between one body and some other planet. There we will not use the term gravity. Gravity is especially used when the body is attracted towards the center of the earth. Earth is important. That's why gravity is related to earth. Let us suppose the radius of the earth is r. Radius of the earth. An object is lying here on the surface of the earth here. So we will be writing this mass of the earth is suppose m. Mass of the earth is m. And the mass of the small body which is lying on the surface of the earth is small m. What is the force of gravity or force of gravitation between them? And that force of gravitation will be towards the center of the earth. That will be according to gravity. This is the force of gravity. The formula will be according to Newton's law G m1 m2 by r square. M1 we can take capital M, m2 is small m, divided by the distance is equal to the radius, we get r square. This force of gravity is called also weight of the body, and weight of the body formula we have m into g. Mass into acceleration, but this is the acceleration with which the body will be attracted towards the center. We write mg is equal to this side, we write g m by r square. This side cancel. We get the formula g is equal to g m by r square. So this is the relationship between small g and capital G. G is equal to gm by r square. This is the formula, or this is the relationship between small g and capital G. What is m? If I read capital M, m is the mass of the earth, because this is gravity, acceleration due to gravity, this is related to earth. Mass of the earth and radius of the earth. If radius, usually the radius of the earth value is 6400 km. if you know the radius of the earth 6400 kilometer and the value of g is 9.8 and capital G value just now I gave, the value which does not change, so we can calculate the mass of the earth. The mass of the earth value comes nearly 6 into 10 to the power of 24 kg. You can do the calculation in calculator and check answer coming here. It will come 6 into 10 to the power of 24 kg. But this is the formula we will be using to find the mass of the earth. So this is the relationship. We continue a little further and we find relationship in terms of density of the earth also, right? G is equal to G mass complement at volume into density. Volume into density and volume of the earth. What is the volume of the earth? Volume of the earth is like a sphere. We will apply the formula of the volume of the sphere. Volume of the sphere formula is 4 pi by 3 r cube. So we write 4 pi by 3 r cube. This is volume. Into density we denote by this line. This is called rho. Density denoted by rho. And denominator at r square. This r square, this r will cancel. And we get the answer G is equal to, the relationship now is coming like this. G is equal to 4 pi by 3 G r and rho. This is the relationship. So this relationship we have between G and G in terms of mass of the earth. This relationship we have in terms of the density of the earth, mean density of the earth, where rho is the mean density of the earth. Where rho is equal to mean density of the earth, mean density of the earth. If question to write down the relationship between small g and capital G, you can write either this or this. Any one of them is correct, but we give preference to this relation. G is equal to Gm by r square. Though you can use this also. So both of them are actually this is derived from this only. So it is all the same. Now next heading is okay. Small g and capital G. One major difference is what the value of G changes from place to place. When we go on high altitude, the value of G will change. When we go below the surface of the earth, that is when we go in the depth, there also the value of G changes. It varies from place to place, and in vacuum it is 0, you know that. But capital G value is same everywhere, even in the vacuum. As long as we are in the universe, so the value of capital G is same throughout. It does not vary, whereas small g is variable. That's why we give any variation of G. Variation of small g, not the capital G is non-variable quantity. So we are doing the variation of G. First case we take with altitude, that is with the height. How the value of G changes with the altitude, with the increase in the altitude. We'll see for that. Let us take a body first on the surface of the earth at A. Now the same body is taken to an altitude at B. The altitude is, the height is h. This height is suppose h. This height is taken h. It is taken to a height h or altitude of h. So first equation we have for the surface of the earth at A. A is the point on the surface of the earth. Let us write the formula. G is equal to, we write formula Gm by r square. Just now we derived and we are using that, equation 1. Now we write here for the point B at a height h. That value, let us say new value G prime, G dash, new value. I will take the same way I will use the formula Gm by, what is the distance of the point B from the center of the earth, from here to here, how much is the distance? This is coming r plus h. Here I write r plus h whole square. This is equation number 2. Now we'll divide equation 2 by equation 1. Therefore, I am dividing equation 2 by equation 1. will divide as g dash by g. When you divide this, this will cancel. Your answer will come r square by r plus h whole square. Here we will do that is g dash is equal to this g and cross multiply g into r square upon, between these two I take r common, within bracket it become 1 plus h by r square. Next I will continue at g dash equal to g r square. This r will be taken out as a square and we will get 1 plus h by r whole square. This and this will cancel. So we get answer that g dash is equal to g divided by this value 1 plus h by r square. This is the formula we will follow for the body taken to some height. The new value of g dash in respect to this value of g will be g divided by this. Because anything whole square is always a positive quantity, that is more than 1, sorry, more than 0. So it can come 1 to anything. So the value, here the value g dash is g divided by that quantity. That is say 1.2, 1.5, maybe 2, maybe 3. Then the g dash decreases because of this. And same thing we can show like this also. G dash is equal to g. Take this up, it will become that is 1 plus h by r minus 2. Then g dash is equal to g. According to the binomial theorem, binomial expansion, 1 plus nh. This will multiply in this. We get 1 minus 2 h by r. Approx. This is the approximate and the approximation. Approx. That means we find the value of g is decreasing with the increase in the altitude. That hence the value of g decreases with the altitude. Because there is a minus sign, g into this g minus this part 2h by r times of g. It is decreasing by this value. So that is when the body is taken to some height, there will be decrease in the value of g. That means there will be decrease even in the weight of the body. Mass will not change. Mass is the constant quantity, but the weight will change. So even the weight will decrease when the body is taken to some height because of decreasing the value of g. Okay. For the problems and all, we will be using this formula. This is formula just to get approximate value. We are doing like this and showing that the value of g is decreasing with the increase in the altitude. G, once the g minus 2h by r times of g will come here. Then by this value, almost the value decreased approximately. Now next heading is with depth. Variation of g value with second part with depth. How does it vary with the depth, and we derive a formula for it. Okay, first that means we are taking the body now inside the surface of the earth. This was the body of mass came here. Now we have taken down there to a depth h. Let us denote the depth also by h only, somewhere here. This is the point B, inside the surface of the earth. Means at some depth, that the depth is h over here. With depth h, we write h. For the surface of the earth, we write the formula g is equal to formula here gn by r square. But here, depth wise, we will be taking the formula in terms of density, not in terms of mass. Because inside, mass will not be constant, whereas density will be mean density everywhere. So we write g is equal to 4 pi by 3 g r rho. In terms of density formula, we have equation 1. Now we write next one for the depth. For the point, let us say for the point B at a depth h, g prime or g dash is equal to 4 pi by 3 g. What is the distance of this point from the center of the earth? All the distance we are measuring from the center of the earth. What is the distance? The whole thing is r. This much is h. This will become r minus h. We have g dash is equal to 4 pi by 3 g. Let us take r common. So you get 1 minus h by r. This is equation number 2. When you divide again, dividing equation 2 by equation 1. Let us divide it. Get g dash by g equal to, when we divide this thing and this thing gets cancelled, we get rho. I forgot to write this into rho. This also rho will also come here. Let us divide the 2. You get the answer coming 1 minus h by r. This will cross multiply and the answer will come g dash equal to g 1 minus h by r. So this is the formula here. That is, what is the conclusion? The value of g, new value of g is increasing here or decreasing? The answer is again it is decreasing, minus sign is there. Previous case also it was decreasing and then approximate value is coming g 1 minus 2h by r approximately. And here it is coming only 1 minus h by r without any approximation. That means hence the value of g decreases. Hence the value of g decreases with the depth. In both the case the value of g is decreasing. Altitude also it is decreasing. Depth wise also it is decreasing. But in which case the margin of decrease will be more? In the altitude or in the depth? Suppose the body is taken to a height of 200 meter above the surface of the earth, and same body is taken to a depth of 200 meter below the surface of the earth. In which case the value of g will be less. I mean, there will be decrease in both the sides. The value of the surface of the earth is 9.8, but when you go up, it will not be 9.8, it will be something less, maybe 8 point something. And down there, it will be how much then? That value will be less than this value or more? The answer is when you go up there, the margin of decrease is more as compared to the same depth below the surface of the earth. Because over there, the formula was 1 minus 2h by r. The amount of decrease is more, and out here the amount of decrease is less. Let us check at the center of the earth. At the center of the earth, we will check. When the body is taken to the center of the exactly over here, that is r and h are exactly equal. If r and h are equal, you can see, have a look at it. If h and r are equal, they will cancel 1 minus 1. The answer will become 0. At the center of the earth, we have h is equal to r, therefore g dash value is coming 0. That means the center of at the center of the earth, the acceleration due to gravity value is 0. Even that is the weight depends upon the value of g. So weight at the center of the earth of a body will also be 0, because the value of acceleration due to gravity is becoming 0. Very often the question is why the weight of a body at the center of the earth is 0. The reason is because the value of g at the center of the earth is 0. And why it is 0? Because of this formula in which h and r becomes equal. So this is the variation of g with the depth h. Now we draw a graph to show the variation of, right on the graph showing the variation of g. The graph showing the variation of g with altitude and depth. With altitude and depth. Altitude and depth is as follows. We draw a graph like this. This is center of the earth. This side is height. This side is height of the h. This side is negative h. Negative h means depth. This side. Depth. This side is depth and this side is height. That means here we write altitude. And this side will be writing depth. First graph we draw for this center of the earth. The value of g is maximum. This is g. Maximum, that is g is equal to 9.8 meter per second square. Okay. And as we go up, the value of g decreases, but it decreases in the parabolic manner, because the graph will be formula is coming as g dash equal to g by 1 plus h by r square. Square is coming to parabolic graph. And other side the equation was coming like this: g dash equal to g 1 minus h by r. This is the equation of straight line. Y is equal to mx plus c form. So it will come straight line like this. and it becomes 0. Where does it become 0? At the center of the earth. Here this point is this is the 0, value of G is becoming 0 here, that is this point will be the center of the earth. Center of the earth. This point is the center of the earth, where the value of G is becoming 0. But with height, the value of G will never become 0, because this is a positive quadratic answer, can never come 0. But it will keep on decreasing, that is for sure. But where it is becoming 0, nobody knows. It is becoming 0 at infinite height. That's why this graph is parallel to this one, is going up to infinity. We don't know where. But here there is an end to it, and that is 0. That is at the center of the value of G becomes 0. So the graph comes like this. Okay, today we are doing this much. Tomorrow, variation of G also takes place with the rotation of the earth. Rotation of earth also changes the value of G. That I will show tomorrow. Okay, thank you.